What is the radius, r, of the inscribed red circle? Label points C, K, E, D, and L. O is the center of the larger circumscribed semicircle. Let its radius be r. Also, let the center of the smaller inscribed semicircle be y, and its radius be equals to q. Let x be the center of the red circle. Join line O, C and line OD. Since line O, C equals line O, D which is equals to line OE, each of these lines equals to R. It implies that angle OC, D equals to angle OD, C which equals to 45 degrees. By Pythagoras' theorem, the square of line C, D equals the square of 2 times Q, which equals 2 times the square of R as shown. It implies that for times the square of Q equals 2 times the square of R. Divide the equation by 4. The square of Q equals 2 times the square of R divided by 4, which equals half the square of R. Take the square root of the equation. This implies that Q equals half product of R times the square root of 2. Also, join line C, K. Line C, K equals Q which equals half the product of R and the square root of 2. Join line D, L. Let angle D, C, L equals theta. It means that A divided by 2 times Q equals cosine theta. Hence, 8 divided by 2 times half the product R and the square root of 2 equals to cosine theta. Cross multiply and we have that cosine theta equals 4 times the square root of 2 divided by R. We call it equation 1. But angle DC, L equals angle CEK which equals theta. From triangle C, K, E. Line K, E equals the sum of line K, O and R which equals the sum of half of R times the square root of 2 and R. It implies that line C, K equals Q which half of R times the square root of 2. By trigonometric identity, line C, K divided by line K, E equals tan theta. After substitution and simplification of obtained values, it signifies that tan theta equals the square root of 2 minus 1 as shown on the screen. By trigonometric identity, the reciprocal of the square of cosine theta equals the sum of 1 and the square of tan theta. Substitute value and we have that the reciprocal of the square of cosine theta equals 4 minus 2 times the square root of 2. After substitution and simplification of values, invert the equation. Then, take the square root of the equation. Cosine theta equals 1 divided by the square root of 4 minus 2 times the square root of 2. Substitute it in equation 1. It implies that cosine theta equals 1 divided by the square root of 4 minus 2 times the square root of 2. Cross multiply and we have that r equals the product of 4 times the square root of 2 and the square root of 4 minus 2 times the square root of 2 in centimeters, or 6.1229 centimeters. Label point P. Join line O, X. It implies that line O, X equals R minus small r. Line X, P equals to small r and line P, O equals R minus B equals R minus 2. By Pythagoras theorem, the square of line O, X equals the sum of the square of line X, P and the square of line P, O. Substitute values. The square of r minus the small r equals the sum of the square of small r and the square of r minus 2. We obtained equation as shown on the screen. Expand brackets, combine like terms and simplify. We have that the product of 8 times small r and the square root of 2 times 4 minus 2 times the square root of 2 equals the product of 16 and the square root of 2 times 4 minus 2 times the square root of 2 minus 4. Make small r the subject of the formula. We have that r equals 16 times the square root of 2 times 4 minus 2 times the square of 2 minus 4, all divided by the product of 8 and the square root of 2 times 4 minus 2 times the square root of 2 in centimeters, or the radius, r of the red inscribed circle, equals 1.673 centimeters to 3 decimal places.